Hello. Hi, folks.
Hi.
Hello. Dodo, I can't hear you. I think you're muted.
Oh, I'm muted. Yeah. Hello, everybody. How are you?
Good. How are you? Long time.
I'm fine, thank you. Yeah, it's been a long time since we haven't talked.
Yeah. I'm guessing a lot of folks will be away this for this meeting because of US Thanksgiving, but
Yeah.
I may be wrong. Who knows?
Yeah, we'll see. I know part of the team took some
Yeah.
time off, but we'll see.
So what's new? What's been up?
Well, I'm eager for the Christmas vacation.
Yeah.
So aside
I
from
saw
that,
that we also had the latest release announced, so that was really cool.
yeah.
Yeah.
We're planning for another one right before the vacation in December.
Oh, great. Okay. Are we also planning to publish a blog anytime soon at Microsoft Open Source?
Mm, I'm not sure. I think someone in the team was working on one. I think Ludwig.
Ah,
I'm
okay.
not sure.
Yeah.
But I don't think it will be before the vacation.
Hmm.
Yeah, it's
Yeah.
too little time left.
True. Yeah. Everyone's been busy too, right? With all these events and everything. We just wrapped up with KubeCon North America. So
Yeah. How was
next
KubeCon?
time. Oh, I didn't go because it was in Atlanta. So there was rejects too before that, which and this was like yeah, I organized that. So yeah, but I did most of the work remotely this time, and thankfully there was someone from Microsoft there I could delegate to.
Hmm.
Worked out pretty well, but yeah, I just decided to sit this one out. I was like, cannot travel and get all of this done for personal reasons. But yeah, I've heard everyone else had a great time and also catching up with some of these meetings, the Cloud Native all team, the complete team meeting and stuff like that. So yeah. Did you happen to catch any of the talks? Or
No, not yet. I know
but
it
you also
takes
didn't
some.
go to Atlanta, no? Or
No, I haven't. I know the talks are published a bit later, but I don't know. Are they open now? Do you know?
okay. Sorry, I lost you for 2 seconds. Sorry.
Oh yeah, I was saying that I don't know if the talks are have been published yet. Do you know? I haven't checked.
For KubeCon,
Yeah.
yeah. They're out. Yeah.
Okay.
Yeah. I don't have the link handy, but I can look for you. Should be out already. Yeah. Sorry. This I think one of those videos. Yeah. I think this is the one. Let's see. Not sure if this is a playlist or if it's just this video, but
Thanks for the link.
no problem.
All right, everyone, we're already 5 minutes past, so maybe it's a good time to get started. Uh, would anyone like to host today? Do we have any volunteers? Going once, going twice. Okay. All right, I can start us off. So, as usual, we're governed by the CNCF Code of Conduct. If you need to refer to what that is, we have a link to that in our agenda. But as usual, please be respectful of others. This is an open space to share your opinions and discuss Hyperlight in general. Um, I'll share my screen with the agenda so we can go over it. And if anyone could take notes while I host, that would be very much appreciated. Okay. Okay, you should hopefully be seeing um, the agenda, my HackMD doc. Uh, okay, so today is the 26th. Uh, please add your names to the attendees list. Um, and whoever is taking notes, just you can add the note taker besides your name. Do we have any announcements?
Just one. Dodo and I were just chatting, so I wanted to let everyone know, everyone who's been to KubeCon North America, the playlist is out. They've released all the talk videos, so yeah.
Nice. Taking note of that. So the playlist for KubeCon NA is out.
Mhm.
Another, you help organize or are the head organizer for Cloud Native Rejects,
Yes,
where gave a talk there with Pedro on Hyperlight. Are those out
right.
yet? Or
No, that's not yet out, but we do expect it to come out this coming Monday. Yeah, I will
okay,
share it with the team once it's out. Yeah.
cool. So if anyone would like to check out the talk that I gave with Pedro, you can check it out then. In terms of releases, I don't think we have any new releases to announce today. I think the last one we did was 3 weeks ago. Although we do have one for Wasm, right?
Correct.
Who made that release? Was it you, Doro? I forget.
Yeah, I made it. I think I posted it on Slack also.
Nice. Anything you wanted to highlight there, or I'll bring it up.
Mm,
Is there a full change log?
yeah, so we enabled debugging WASM modules, native WASM modules for Hyperlight WASM, and also added guest tracing support for the runtime itself of the guest, not the WASM modules.
Cool. That's awesome. This one was dependent on a. Was it a feature that we were waiting on Wasm time?
Yeah, it was dependent on not a feature, was a change I made and merged it upstream that enabled guest built-ins. It was a feature of wasn't time to build for non-standard targets.
Cool. Exciting to have that out.
Yeah.
If people want to try out the debugging, is there a tutorial they can look at or
Um,
some documentation they can check out?
I think I added some documentation, some some info about this, but I have on the agenda, I guess, debugging, and I can show off the WASM also at the end. I don't think it would take much.
Cool. Yeah, excited to see it. So, oh, you have it there. Nice. Cool. Yeah, and if other folks want to check out, this is the link for the documentation that Doro added. And we'll see the demo soon. All right, so that's the announcement of the playlist and the announcement of release for Hyperlight Wasm. Anything else missing? Any features we're working on core or Wasm that folks want to highlight? If not, I do have one thing. For my talk at Cloud Native Rejects with Pedro, we opened the Hyperlight Navix repo, which is also like Wasm, a sister project to Hyperlight that allows you to run workloads that depend on the Navix OS inside of Hyperlight. One benefit that you get out of the gate with this is that Navix has support for Python. So that's something that we couldn't do before with Hyperlight, but now if you like to try out running Python apps, you can go to this repo and check out the guest examples. You'll see we have this hello.py, and you should be able to just run it. And there's documentation on how you can do that. Essentially a simple cargo run, that guest example. In this cargo run, specifically, it's running a binary. So Hyperlight Navix, you have the library as usual, like Hyperlight core, Hyperlight Wasm, but you also have this CLI that you can just run, and it makes it pretty easy, and it does dynamic dispatching across the different binaries that Navix supports, like for running JavaScript, QuickJS, for running Python, Python 3, and so forth. So yeah, do check it out. I'll note that there as well. Oh, someone got it. Thank you. And
Sorry, I have a
yep,
question here then. I was
yeah,
wondering,
go ahead.
is there a blog planned for this? Perhaps a Microsoft open source or maybe a CNCF blog post? Particularly because this seems like it includes another language.
Yes, I
And
am actually currently working on a blog
oh,
post, so
okay,
that's a good
great.
cue. Blog post incoming.
Okay, wonderful. Great.
Thank you, Vanessa. So I think that might cover the announcements that we have for today. In terms of discussion items, I think we can do two things. We can go over the issues that we have, and then also show Doru's cool demo. Considering I have the screen sharing, do we want to check out the issues first and then do the debugging, or Doru, do you want to do the debugging first? Does that work? Yeah, cool. Okay. First, let's check out issues with the needs review label. As usual, assigning the needs review means that we will discuss this item. So if there's an item that you'd like to discuss in a future meeting, add the label and we can go over it. James, I see your hand up.
Oh, yeah, just also, I think we have Shalish on the call today, so I don't know if how he's dealing with his PR. We'll make sure it's discuss that. Questions. So,
Your audio was a little bit iffy for me, but I think you said that. Let's check on Shailesh.
Yeah, I submitted that PR and just waiting for review.
okay, cool. Yeah, we can do the issues and just want to make sure you have time. Yeah.
Yeah, Shailesh, do you have any questions about this PR or
No, I have no questions.
comments?
So Ludwig suggested some changes. I did those changes, and that's it.
Cool. Ludwig, did you have any comments there? Anything that you also wanted to discuss?
I don't think so. I'll take a look at it. Um, yeah, maybe some other people can also take a look because I'm
Yeah, I
not
will
too
too.
familiar with WASM cogen.
Cool. I'll take another look. Wasn't sure. Sorry.
Yeah, yeah. Thank you, Shailesh. I'll take a look.
Yeah, thanks for the contribution.
Sure.
Lucy has worked extensively on the host by Gen stuff in core here, so maybe she can take a look as well. Okay,
Sure, I'll take a look at that tomorrow.
thanks, Lucy. With that, back to the needs review. We have 3 issues to discuss today. First one is from Ludwig on remove misleading boolean, return from interrupt handle, kill. Did you want to chat about this one, Ludwig?
Mm, yeah, so kill returns a Boolean, and the purpose was initially or originally for the caller to know whether the kill worked or not. So, for example, if the sandbox was not running, it returns false. If it was running, it returns true. But now it's not actually that case anymore because it still returns true when it interrupts the vCPU by sending a signal. But if it sets the flag before the vCPU has started running, that will prevent the vCPU from running, which is possible if you call kill after the guest function call has started, but before he's entered the VM, it will still return false. So I just don't think this Boolean is very useful anymore. So I'm considering removing it.
Got it. Yeah, that makes sense. So would you just make the function not return anything? Or a
I
result?
think so. Yeah, either a result or nothing. I'm not sure.
Okay. Any comments there from anyone else? Or if not, I'll just add this as confirmed. Remove the needs review. Um, maybe bug. Is this something you're planning to work on soon, Ludwig? Or I don't know if you're working on it or just an open issue. If not, we can put it in the backlog.
No, you can put it in the backlog.
Yeah. All right, 2 more. Um, GDB potential bug due to double address translation. This one is also yours, Ludwig.
Yeah, I think this is just a bug we might have. I didn't investigate too deeply, but I found that we translated guest twice, which sounds bad. Maybe
Um,
Dora knows. Yeah, go ahead.
Sorry, Ludwig, for interrupting you. Yeah, so I think this is already caught in issue 501, and you can add it as a child or something like that. It consists in multiple issues that could be solved. So I think putting it as a child of this one should be fine.
Is it 46? Yeah. Okay.
And I think you can add the good first issue flag onto it. I don't think it's difficult to solve this.
Cool, thanks. Mm, I'll just hit it confirmed. Cool. So yeah, if anyone's watching this and would like to work on a good first issue for Hyperlight, we have one right here. Then, last needs review that we have is exception handler with instruction that requires 16-byte alignment causes GP fault. from James. Did you want to discuss this one?
Yes. Essentially, so our exception handling code, we store a bunch of context, hand it off to the exception handler, and then restore that context. So we're storing that context, we're pushing an odd number of registers, which ends up with a pay byte alignment. And some instrumentation code got added to one of the functions that called during that. And so during a release mode, it got optimized into this SMD instruction, and that requires 16 byte alignment. So it caused a like a general fault, and then it actually resulted in a stack overflow because we were cycling through the exception handlers. So yeah, so I opened a PR to fix this. So I think there's a link to PR. And then I updated the documentation. Looks a little bit better options.
Yeah, this is the ABI requires the stack to always be 16 byte aligned. So if we were generating non-16 byte aligned stacks somewhere, that's really bad.
Yep.
I will take a look at your PR tomorrow.
Cool. Yeah, I'll have a look as well. Considering we have a PR, I'll also assign it to our current milestone.
Yeah, in the PR, I added a test that failed. I just put some SIMD instructions in the handler. It failed, and then I fixed it and it passes. So we have that resolved.
Nice. Yeah, thanks for the quick PR. All right. With that, I think we just have to check if there's any issues with no milestone. Or just a GDP one. I think. Do we feel like this is a backlog item or backlog?
Yeah, backlog.
Okay. Up next, let's also check Hyperlight Wasm if we have time. Yeah, things like we don't have anything here. I feel like no milestone might be a little bit iffy to check. Yeah, but I think this is fine. It's something that we'll probably do some cleanup later with when we create our project board. It's something that we'll plan to do so we can better manage the multi-repo setup that we have in the org. But these are all old issues from September 13th, so we don't really have to discuss them here. Okay, I think we have about 20 minutes left in the meeting. After doing some issue wrangling, usually we would go over our current milestone. Do we want to maybe spend 5-ish minutes there before we go for the demo?
I'd say we go for the demo.
Go for the demo?
Since we've got one.
Yeah, I'm good. And also we've done this, we checked out the milestone just recently, and we have most issues here assigned. This one is not assigned 21, but James already has a PR, so I think we should be good, and we did some prioritization, so we might be overcommitting a little bit, but this should be at least the top issues reflective of what we're currently working on. So I think we're looking pretty good there. And with that, Doro, the floor is yours. As soon as I figure out how to unshare my screen.
Okay.
Or if you can take over. Oh, I think I got it.
It doesn't let me take over. Let me try again now. Okay. Okay, let me know when you see my screen. So I prepared a few slides just to explain the state and what this tries to do.
Nice.
So
yeah, I can see it.
yeah, the images were with the help of Copilot, so don't take that into consideration. Okay, so Hyperlight guest debugging. This is a high-level overview of what we have now in Hyperlight. So the role of the debugger in debugging the Hyperlight guest is we want to inspect, modify, and step through execution to diagnose issues efficiently. And the core capabilities that we support now are breakpoints, single stepping, reading registers, and memory inspection. How that is done is the debugger communicates with a GDB stub that's inside of Hyperlight, and it exchanges commands, and the stub itself implements what those commands mean. I'll show you later how that works. And what this GDB stub does in Hyperlight host is it takes debugger commands as input and interprets them, as in it reads and tries to make sense of what those commands are. It implements the protocol, the GDB protocol. It takes actions to those commands. That means for each command it receives, there's a corresponding action that it does. For some of those actions, it is a direct action on the vCPU, which means running or stopping it. For others, it's modifying the memory, which doesn't affect the CPU running. It needs to be stopped anyway. And afterwards, it sends back command output, a response, so that GDB knows, the debugger itself knows what happened. Okay, how that's working. This is it's a more in-depth description of what I already said. So how about I show you an example first so that you understand exactly what's going on. So I draw a little diagram here so we could understand better. So what's happening is we have an application that runs a hello world, and this application of ours instantiates two sandboxes, one that enables debugging and one that doesn't enable debugging. And usually what happens when a sandbox runs that doesn't have debugging enabled is it receives an evolve command from the API, from the Hello World application, which translates into an initialize call inside the hypervisor, and that runs the vCPU, which runs the guest VM. And afterwards, for a corresponding call of a guest function, it calls the dispatch call from host hypervisor API inside the Hyperlight, which runs that function. What's different when the debugger is present is we have a communication set up between the debugger and a stub, which is run on a separate thread on Hyperlight. So what that does is that communicates with the GDB, and for each command, it knows what to instruct the vCPU to do. So for example, before initializing the guest VM, it sets a breakpoint on the entry point so that the guest stops at the entry point and then runs initialize. After this initialize runs, it will have stopped at the breakpoint. So the guest VM exits and Hyperlight host gets back control, and the GDB stub reports to the debugger that the VM has stopped. And the debugger can send commands, and the stub itself instructs the vCPU what to do afterwards. So I'll show you this example now live. Okay. So on the left-hand side here, this is the guest debugging application we have as an example in Hyperlight. And as you can see, what it does is it initializes a sandbox with debugging enabled. It uses this configuration, which enables debugging, on port 8080. What that means is the Hyperlight host will listen on this port for an incoming connection from the debugger, and after the connection is done, the debugger can interact with the target.
Could you make the text a little bigger?
Oh, sure. Is it better now, or do I need to make it bigger?
I think that's better. Thanks.
Okay. And here we have the second sandbox that doesn't have debugging enabled. So what we'll do here afterwards is we install some host functions just to showcase the scenario where you want to install a host function. And afterwards we call evolve. What that does is it initializes the memory and everything that the VM needs for it to run guest functions. So what we'll see here is after the evolve is called, so let's run it so we see how it's done. Okay, so I'm running cargo run. I pass the feature GDB so that this configuration here enables the listener for 8080 port. And once I run it, it will just hang waiting for the debugger to attach. So now I have a configuration here for VS Code that uses LLDB or GDB. You can use either of them. I'll use LLDB in this example because the extension works better. So I'll attach using the remote LLDB configuration. You will be asked to provide, this is a configuration I made. You will be asked to provide the path to the symbols to the ELF file used to instantiate the guest. After you provide this, it will stop at the entry point, as I said, because the Hyperlight host sets a breakpoint there. And we can see now we can step through this code. I have already added some breakpoints. I added one before calling the Hyperlight main function. So if I skip, it will just run. And you'll see here that we have some calls made after the evolves. After the evolve calls, we have a call on the debug sandbox to the use SSE to register, and a call to print output. I have already added some breakpoints here. So I think one is here, use SSE to register. And once I hit continue, what will happen is the Hyperlight guest will continue executing. It will exit the entry point, and the Hyperlight host will continue executing with the SSE function. So we will see it stop here in the use SSE register. And we can skip, we can do whatever we want here. We can inspect registers, we can even write memory. And I also added another breakpoint to the print output functions. We can see that we're running print output here. And if I hit continue once again, it will finish running that SSE function and stop here at simple print output, which we can see what it does through. So I'll skip this function. This is the host function call. It calls back into the host to do the printing of the message. So after I skip this, we will see the message printed here on the bottom in the terminal. So the host itself does the printing, not the guest. Now I'll continue and it will stop and it will print the same message from the sandbox that didn't have a debugger attached. Okay, this is the first example. Are there any questions until now? I have another one, which is a little bit more complicated.
You didn't show it, but you can also step through the assembly code. Which,
Through the,
oh,
I don't get you.
I don't know why it's not working. Can you hear me now?
A little bit better, yeah.
I was saying you can step through the assembly as well.
Yeah, I'll show that off at the next example. Okay, so for the next example, what I've done is sometimes you would like to debug at the same time the host application and the guest so that you could step through the calls you do from the host right through to the guest and see that propagate. So what we'll do, what's different in this case is we have two debugger instances. One attaches, as we've seen already, to the guest we want to debug, and the other will attach to the application. I will start the application with the debugger attached, and let's do this now. So I have another configuration here, guest debugging called, and that what that does is that runs the guest debugging application with and attaches the debugger. I've already added some breakpoints here so that it stops. Okay, so run it. Okay, so we see it stopped here. We can step through it. And I'll do this. I'll add another breakpoint here and run until now. So we can see that once I hit the step over button, it will just hang. It won't stop at line 72. It's just, where is the terminal? I think here. It will wait for a connection from the debugger to attach for the guest VM. So I'll do that now. I'll use the same LLDB configuration to attach. Okay, so now we have, you can see, two debuggers attached here. So I can now do what I've already done at the previous example. Can continue and now after it calls hold, we will see that it will stop at line 72 on the host side. So the function calling the guest will yield back control to the host. Okay, so now we're at the eval for the other sandbox. It will just step over. So now we have the breakpoints already set up from the previous example. If I hit continue, it will stop in the use SSE2 registers. And I can show you here what James suggested, which is we can open a disassembly view and we can step through the code in assembly. So you see this CC instruction here because this is the breakpoint I've added. So this is what it looks like. This is a software breakpoint, which means that at the exact address, the Hyperlight host adds this instruction so that when the CPU encounters it, it stops execution and yields back control. So if I step into now, it will just continue executing. Okay. I'll continue this now, and we're going back to print output, and we can see that from the host, if I now step over it, it will call into the guest, and this is how you can debug if there's an issue with something that starts from the host and arrives in the guest, and you don't know what exact parameters were sent and so on. We can also see where the execution started. So we see that it started in this function, and then this function called internal dispatch function, which in turn called the guest function, and in turn did all this, and it finalized with calling the actual function that the user defined in its in his application. Okay, so this will do the same thing as before. If I step over now, we'll see the message being printed in the terminal. I think this is a different terminal. Yeah. Okay, so yeah, it will yield back control here, and we can continue until the end. So this is how you can set up a debugging scenario, debugging session for both host and guest at the same time. If there are any questions, please ask them now. I have one more thing to show afterwards, which I barely prepared, but I'll give it a try. So are there any questions?
No questions for me, but super awesome so far, Dor.
Okay, I hope I explained it with the best words I could. Okay, so I'll show you how to debug a Hyperlight, a WASM module in Hyperlight WASM. Okay, so I'll use the same. We have a guest debugging example here also, which what it does is it runs some of our WASM examples we have in the repository. One is Hello World, and for the Hello World one, it is located here. It's a C file, so this one is compiled to a WASM module. And also we have Rust WASM examples, which are here, and it's a Rust module. It's a Rust binary. Okay, so I'll run the example here first. It's the same command, fortunately. And the first thing that you could notice, and it's different, is it will be printed a warning. This is the best way I could do this until now. So what happens is the WASM module is not run directly. We have the runtime, a binary guest that consists of the WASM time runtime that is run instead of the guest, and that WASM runtime runs the WASM module. So we need the debug symbols for that WASM runtime we have inside. So I'm using this path that I was printed here, and I'll use, so as you can see, it's hanging, waiting for a debugger to connect. I'll use the same remote LLDB attach. We are using the same port here with debugging enabled. This is a API we've added to the sandbox builder that enables automatically the debugging for that sandbox. So once I run this, I will paste the WASM runtime path, and it will stop at the same entry point we had because it's a guest. So what's different is Hyperlight main here, when being called, it will do some different stuff. It will register some functions which initialize the WASM runtime, allow loading WASM modules, and so on. And I added some breakpoints here for when we load the module, and some breakpoints when we call a function. I'll show you here when we call the function in that module. So if I run it, if I continue executing, we'll see it stops at load WASM module. And what this does is it loads a module, and the first module it loads is this Hello World AOT. So if I continue executing, it will take a while because the WASM module has debug symbols in it, so it's bigger and it takes a while for the WASM runtime to load it. Afterwards, I'll continue executing until we want to run a function. So the function we run in this example is the hello world function here. So I want you to see that if I step over now, this is the function call that the WASM runtime does to call the function in the WASM module. So if I continue, I have a breakpoint there. We'll see it stopped at the hello world function we wanted to call in the WASM module from the C file. We can step, we can do whatever we want. The same support for guest debugging is supported here. So okay, so now I'll continue executing and we'll see the next WASM module to be loaded. And this one is the Rust WASM samples AOT, and it calls the add function. And I'll just continue right until the function call. This is a bigger WASM module. Come on. Okay. Okay, so I'll continue executing again and it will stop in the add function because I have already added some breakpoints here. So what is different is in case we have a runtime that modifies the symbols at runtime, the GDB offers an interface called, I don't remember exactly, it's a GDB something interface. And what that does is it registers in a place in memory pointers to the modules being loaded, to the symbols. And once it modifies, the runtime modifies that location, it triggers a breakpoint on a specific symbol so that GDB knows that table of symbols has been altered, so it knows to take them from there and load them. So that's how it figures out that now we have a different module that has different symbols and it can stop and do whatever the user wants there. So yeah, this is the third module being loaded here. It does a call host function, and this is a little bit bigger. It will take a few seconds to load, and I'll just run until I didn't have a breakpoint there, so yeah, sorry, it's just run to completion. I think we can see here in the terminal that it printed the message, it did the addition, and the host call did return 6. It was an addition, I think, something like that. So anyway, this was the demo for Hyperlight WASM native debugging. So questions?
Super cool. Super cool to see it going from like our library code to the C that was compiled into WASM and also Rust. And
Yeah,
question.
Go on. Sorry.
Yeah, question for me. So you showed debugging WASM modules. Is there a restriction on debugging WASM components, or should it just work the same?
No, it's the same. I checked it. It works. I didn't take time to compile the components, and it's just it was an issue of a demo. We already had this demo for the modules and not one for components. So that's why I use this.
Cool. Makes sense. Yeah, and I think the docs mention components too. So we think if anyone wants to try out components, they can check out the docs. Another question for me. So you also showed the double debugger for that example too from the previous demo. Because we have that support in core, right? I guess we can do that with Hyperlight WASM too, and it should work the same.
Yeah, exactly the same.
Nice. Yeah, awesome work, Thor. Looking cool.
Okay, so if there aren't any other questions,
Probably the most times we've ever had in this meeting. So
Stop sharing. I can share also. I have that blog post that I did a couple of months ago with Hyperlight guest debugging. It's a bit old, let's say. We've added some functionality in the meantime, but if people are interested, that can be read. Okay, that's it from me. Thank you.
thanks. So I think with that, we don't have any more discussion items on the agenda. We're also, I think, a little bit over time, but any final questions or comments from anyone else? Any final PSAs? If not, I think we're good to close for today. So thanks everyone for coming, and I'll see you next time.
Thank you. Thank you. Bye bye.
Thank you.
Bye.
Bye.